Hi gents, we're going to continue on with exercise 4D. We're going to do a properly tricky one now. So we'll do question 20 and it's on page 59. I wanted to do one that involved an airplane just as well as doing boats and rivers and all the rest of it. Okay, so with this one here, what I suggest you do is I suggest a quick little diagram for it, just so you understand exactly what's going on. It says the maximum speed of an airplane is 200 kilometers per hour. Find the maximum speed with which you can travel due north if there is a northeast wind blowing at 50 kilometers per hour. Note it says a northeast wind is a wind blowing from the northeast. Okay, so if you've got a wind blowing from the northeast, in order to go directly straight, you're going to have to head in on a particular direction. So for instance, let's say you were to go in this direction, what you'll end up doing is you'll get blown by the wind, so that actually you'll end up going directly north. So it'll look something like this. Okay, let's fill in some details so we know about it. And actually what's really important here is just to talk about what's what. This here is the velocity of the wind. Okay, we'll call it that. Now this thing here, we want the plane to actually be going due north. That's what they ask us to do. So this thing here is going to be the velocity of the plane. And this is the velocity of the plane with respect to the wind. Okay, so we have velocity of wind, velocity of plane, and velocity of the plane relative to the wind. Okay, now we can actually fill in some of these things already. Okay, we will know some of them. So we can say nice and easy for the wind, since it is going directly northeast. Okay, it's coming from northeast. Just making sure that was northeast. It is, yeah. What we're saying here is that, well, actually we kind of have to draw this out. Okay, so if it's doing that, and if we have this as being 50, which we do, we can work out x and x, because we know that it's at 45 degrees if it's directly northeast, and it is. So we get x squared plus x squared equals 50 squared. We end up getting that 2x squared is 2500. X squared is 1250, and x is equal to the square root of that. And if I just type that in, it's going to be 25 root 2's. Okay, so we can say what this thing here is. Now remember, it's going left and it's going down the wind. So left is minus 25 root 2 i's. And down is minus 25 root 2 j's. Okay, so we have that one done. That is the wind. So it's now about getting this one. So this one's a little bit trickier. We want it for that relative to that. So here's the way I would be thinking about it. Okay, I would do it like that. We know what the magnitude of the velocity of the plane relative to the wind is, and we're told that that is going to be 200. Okay, we're told that that bit is 200. So this bit here is going to be 200 cos, and we'll call this angle here alpha, cos alpha I, plus 200 sine alpha j. If you're not sure of that, what am I doing there? I'm calling this thing x. X is how far over we've gone on the y-axis. Okay, and if you think about it, the cos of alpha is equal to the adjacent, which is x, over the hypotenuse, which is 200. So we have x is equal to 200 cos alpha. I'm sure you know that already, but just a reminder in case you've forgotten everything in the last 2 months or so. Okay, we have that. Next thing that we're going to do is we are going to now, and the same is obviously true for y. Next thing we're going to do is we're just going to remind ourselves of this formula here. the vector of the plane relative to the wind is the vector of the plane minus the vector of the wind. And therefore it is also true that VPW added to VW is equal to VP. Okay, so that's actually going to be quite handy. What we really need to do is we just need to add together these two things here. Okay, we add them together, and that'll equal to the plane's vector. Okay, when we add the I components, when we add them together, we're going to have 200 cos alpha minus 25 root 2's. Okay, and when we add the j components, we're going to have 200 sine alpha minus 25 root 2 j's. Okay, that's what we have. Obviously what I'm just doing is I'm just adding those two things together and factorizing the I component, if you want to think of it in that term. Okay, so now we know about the plane. Okay, this is what we were interested in. It is headed north. Well, if it is headed north, that tells you something very specific. It means that this thing here, if you were to write it with i's and j's, the i's would have to be 0. And we have written it in terms of i's and j's, and it has to be that the i's are 0 because it is headed directly north. Okay, so it turns out that we can say that 200 cos alpha minus 25 root 2 is equal to 0. So we have 200 cos alpha is equal to 25 root 2's, and cos alpha is equal to 25 root 2 over 200. So that's cos alpha that divides in 8 times root 2 over 8. Now, what was the actual question? The question was, what is its speed? So we really just want to know how fast is it going up. We're really trying to get the magnitude of it. We already know that this thing is 0. We know that the I component is 0. So really we're only interested in what is the j component. So to get the j component there, all we need to do is find out what sine alpha. So again, you can find out what cos alpha is. You can find out what alpha is from cos alpha by doing the cos inverse function. It doesn't look like the nicest number that I would know off the top of my head, but let's just give it a chance. We'll see if it's anything decent. So it's root 2 over 8. So that's adjacent over hypotenuse. So we can say here x squared plus root 2 squared equals 8 squared. That's x squared plus 2 is equal to 64. And x is equal to root 62. I don't think that's a particularly nice number, root 62. So sine alpha, anyway, we know is equal to root 62 over 8. That's what it is precisely. So if we're trying to find out what the magnitude or the speed of this thing is, it is whatever the j value is. I mean, you can, if you stick that thing in there, it's just going to give you an answer of 0 for all the i's. We can be sure of that. So this one's going to be 200 sine alpha, and sine alpha is root 62 over 8 minus 25 root 2. Okay, I don't think that that is a particularly nice number, so let's just see. That would be 25 root 62's. Yeah, it's 25 root 62 minus 25 root 2's. I mean, I guess you could just call it this. Okay, and that's its speed. If we want to know what that thing is, minus 25 root 2's, like to some sort of decimal places or so. It's very close to 161.5, and those were going to be kilometers per hour. Okay, that is your first example of like a properly tough one with this, where you really have to think about it. Diagram, really important. Being able to label the wind vector and the vector of the plane relative to the wind, and then the vector of the plane itself. That's really, really important. You write them in terms of i's and j's, and then we use our little formula that we know of here. Okay, When you have that, you slot them in. With these, typically one of them is going to be like due north or due east or something like that. So you can say that I is going to be 0 or J is going to be 0 depending on what it is. It might be that you're headed directly, I don't know, southwest or something like that, in which case you'll be able to equate the I's and the J's. Let's just take that example. If something was going southwest, okay, what you would do is you would take the I value and you would say that it's equal to the J value if it was directly that. Okay, and actually the signs would be the same. Be careful, sometimes you'll have to change the signs on it. For instance, in that case, both signs would be negative, so that's grand. But if we're here, you would have negative I's, but it would be the same number of positive J's. So when you're doing your equation, you need to bear that in mind. You also need to be careful of the signs just in general. So in this case, it was important when we were talking about the wind that the I's and J's were both negative, since it was going left and going down, whereas with the vector of the plane relative to the wind, it's important that they're both positive, which won't always be the case. In this case, it's going right and going up. So just watch out for those things. They're sort of important. I think a good one to do here, there's another airplane one, 2 airplane ones that I can see here. Question 16 and question 19 from page 59. I would suggest that those are the ones that you give a try now, just to make sure that you can do it. As always, if you can't do it, just drop me a message and let me know. Thanks.